Okay, our meeting is starting now. Distinguished guests, ladies and gentlemen, good morning, good afternoon, and good evening. Welcome you all to 2024 International Online Seminar, Bamboo in Africa, Pathway to Sustainable Construction and Development. The seminar is organized by INBAR and INBAR Bamboo Construction Task Force. My name is Liu Kewei, the coordinator of Global Bamboo Construction Program of INBAR, as well as the coordinator of INBAR Bamboo Construction Task Force. Welcome you all to join this learning journey. We provide simultaneous translation for this seminar. You can choose English or French. First of all, let me introduce our distinguished speakers. Welcome Mr. Durai Jayaraman, Director of Global Program of International Bamboo and Rattan Organization. You can open your microphone and say hello to everyone.
Hello, glad to meet all of you.
Okay, thank you, Durai. So welcome Dr. Edwin Zeng Escamilla, Chair of INBAR Bamboo Construction Task Force, Senior Assistant and ETH Zurich's Chair for Sustainable Construction.
Thank you, Kewei, and also from my side, welcome to everyone. Very happy to have you here.
So welcome, Edwin. So let's welcome Professor Olukayode Ogunsanwo. He is a professor of University of Ibadan of Nigeria. So you can you hear us? You can see something?
Good afternoon.
Okay.
Good afternoon, good evening, everybody.
Okay, thank you. So let's welcome Leo Pele Marian, Assistant Professor and Senior Structural Consulting Engineer at Addis Ababa University of Ethiopia. Welcome.
Hello. Good afternoon, everyone.
Welcome. So the third speaker, I don't know whether he has arrived. He is Mr. Jan-Henrik Power. He is an international consultant and engineer on solar energy. He told us he will arrive a little bit later. So let's welcome Mr. Durai Jayaraman to deliver the opening remarks.
Thank you, Kewei, Your Excellencies, distinguished guests, ladies and gentlemen. So good morning, good afternoon, and some good evening, and a warm greetings from some Beijing. I am honored and delighted to deliver the opening speech for this event, which is titled 2024 International Online Seminar in Bamboo in Africa, the Pathways to the Sustainable Construction and Development. In this webinar, we will focus on the African continent, exploring the multifaceted role of bamboo in the sustainable construction within its diverse ecological, cultural, and socio-economic landscapes. Bamboo is traditionally used as a construction material in Africa, Asia, and Latin America over the centuries. The research and innovation in the past few decades have enabled the bamboo's usage as a contemporary construction material in its original form, as well as in engineered forms. with the development of the modern construction techniques and technologies, the use of bamboo in architecture has gradually developed from a very small size vernacular structure to a construction of a medium or like a very big infrastructures and like some public building. Since the pandemic, as you know, which came and stuck us in the year 2020, it is already 5 years for us, but we have his online seminar on the bamboo construction. Based on the great impact of INBAR's online like webinar speed series on the bamboo construction in the past year, this year we are going to focus like particularly on Africa. This seminar will emphasize Africa's unique challenges and opportunities, aims to uncover innovative uses of bamboos that cater to the local needs while promoting global sustainability standards. By hosting this conference online, we ensure broad accessibility and encourage participation from the global audience, which includes students, academicians, researchers, industry professionals, and interested general public. This inclusive platform will foster a comprehensive dialogue on the education initiatives, technological advancement, and research breakthroughs in leveraging bamboo as a sustainable construction material in Africa. This year, we will have 3 webinar sessions and 9 speakers from Nigeria, Ethiopia, Germany, Ghana, Rwanda, Uganda, Kenya, Netherlands, and like Mozambique will deliver presentation on the various like some subject. Several INBAR staff as well as INBAR construction task force like some members are going to join as chairs to chair the session and also join in discussions in a friend session. So with this, I wish all the sessions a great success, and I wish all the very best. Thank you very much.
Thanks a lot for Durai's opening remarks. As Durai said, we organized this kind of a session already, so 5th year. So thanks a lot for your always support, because for each year you come to join us. So let's welcome Dr. Edwin Zeng Escamilla to deliver the second opening speech.
Okay, thank you, Kevei, and thank you, Durai, for joining us. Following up, good morning, afternoon, and good evening for everyone. It's always very nice to see that our seminar has such a global reach. Before and first of all, I would like to extend my gratitude to everyone who helps organizing this event and participating on it. Is not easy and is a very important work that needs to be acknowledged. So really, thank you very much. I think beyond what we have described and learned about the seminar, the vision and the importance of this meeting is that we need to start looking for research from Africa. We need to focus on endemic species from Africa and their potential for construction, but also understand the traditional vernacular construction techniques and elevate them to an engineering level, as had happened with other construction techniques from Latin America, for instance, where we can develop and precisely design buildings to be resilient and safe for the users. This is a task that we have in front of us, but is necessary and will really enable to develop a more safe and sustainable built environment in Africa. we need to also recognize that bamboo is not merely a construction material. It's a regenerative resource, and I need to be very clear on that. With bamboo, we have the potential to transform the built environment, to revitalize local economies, and all at the same time improve local and global environment. With bamboo, we do contributions not only to our own carbon footprints, but can contribute to the global challenge that we have ahead. Bamboo provides us with a distinct avenue for developing resilient, sustainable, and cost-effective infrastructures, and we have examples all over the world demonstrating that it's possible, cost-effective to do it. We need now to develop the specific standards that are required to address the needs in Africa. With that said, I'm very, very happy to open and declare open the 2024 International Online Seminar Bamboo in Africa. I hope that these presentations are inspiring and interesting for everyone. I hope that we can create a wider network of people working in bamboo from all different sectors, and that we together build a more sustainable future. I thank you all again for your contributions and for your participation in these next 3 sessions, and I hope we all will have a wonderful learning time. Thank you very much.
Okay, thank you, Edwin. After the opening words, Edwin and I will moderate the whole session, and Edwin will be responsible for Q&A session. So during the presentations of all the speakers, if you have any question, you can type them and let us know. Then Edwin will ask all the speakers after they complete their presentations. So let's welcome the first speaker, Professor Olukayode Ogunsanwa. He is Professor of Department of Forest Production and Products of University of Ibadan, Nigeria. He has supervised 17 PhD theses in the area of wood and fiber science, with over 20 publications on bamboo utilization and technology in reputable outlets within and outside Africa. Over the past years, he has been a passionate crusader for sustainable bamboo utilization for poverty alleviation in Sub-Saharan Africa, especially Nigeria. His research focuses on physical and mechanical properties of bamboo, environmentally friendly preservatives for bamboo preservation, bamboo lamination technology, including finger jointing and cottage level bamboo technology for poverty alleviation in Nigeria. So between 2003 and 2023, he has presented several material at both local and international conferences. He is also a fellow of several scientific committees, as well as a consultant of several international organizations. So let's welcome him to deliver the first presentation. Professor Ogunsanwa, you could share your screen. Open your PPT. Can you hear us? So maybe there are some problems for internet. So I see Professor Leo is there. So maybe we can move to the second speaker. So let me have a short introduction to Professor Leo Haley Marian. He is an assistant professor and a senior structural consulting engineer at Addis Ababa University. He learned his bachelor degree in civil engineering from Havasa University, Ethiopia in 2007 and got his master degree in structural engineering from Addis Ababa University in 2012 and got his PhD in sustainable infrastructure design from the same institution in 2023. He is deeply passionate about advancing infrastructure and sustainable design. His research interests including structural design, bridge design, sustainable and circular design, and advanced structures. He focuses on lightweight, bio-based sustainable materials and sustainable structures. Currently, he leads several projects under the Sustainable Structural Lab, including initiatives such as the Bamboo and Earth Sustainable Housing System. So let's welcome Professor Leo to deliver his speech, his presentation. Professor Leo?
Hello. Thank you very much.
Okay,
Yeah.
you can start.
Thank you very much. Good morning, good afternoon, and good evening. It's been an honor to be part of this online seminar. I'll be presenting about structural design philosophies and codes of practice for bamboo structure provision, which is a study conducted in my university together with colleagues. So we try to study the existing literatures through systematic literature review, and we have tried to collect data from scientists through Delphi survey. Then this research is mainly based on this approach. So these are some of the outlines. I will start discussing about the structural design prospect, what are the directions, the approach, and then we'll try to state some of the philosophies of structural design that exist in the scientific world, and again, even the philosophies behind the code of practices would be discussed in this subtopic. And again, we'll try to see what are the key parameters to devise structural design philosophies will be presented. And then bamboo structure design and code of practice toward this bamboo structures would be discussed. And finally, we'll forward conclusions and future remarks. Basically, the task of structural design involves defining or proportioning sizes of structural systems to meet material strengths and efficiency, and again durability demands, which should be fulfilled in the design life or service life of that structure. Of course, there are key concerns while we employ the duty of structural design. Of course, the first one is material behavior, which is very important, how it behaves under impacted effects. Of course, this behavior is determined by either testing criteria together with a design philosophy or with a design competition. Of course, the second key concern is usually employed in the structural design is building efficiency, which is very important to the occupancy. Unless that the built infrastructure is efficient, would have an issue of structural provisions. Yes, the design of such structures which provides functional space should follow in acceptable probability of remaining fit to the function within that intended design life or service life. Of course, within the budget for that structure, okay, budget limit. And the other parameters that should be kept in when we design and construct structures is its reliability, how it sustains the actions, the effects, both during the execution, during its service or operational stage. It should be within the allowable reliability extent of structure. When we consider these provisions of structures, of course, we cannot really eliminate the impacts or hazards. Of course, that damage or effect should be limited, should be within the form that we could handle that effect. Okay, so as much as possible, reducing the hazards is one of the limiting effect. And if not, and if there is a huge hazard existing, we need to develop a structure form that try to understand and respond to that effect with a minimal effect, a minimal damage limit. Of course, that form would also need to help to survive the accidental effects while we remove the individual element. For example, if we have a bundled column of bamboo, so if we remove one element, we should minimize that effect using the structure form so that we try to eliminate the collapse scenario. Again, the structural form, by stating a very outstanding structural form in the design process, would provide sufficient continuity between the individual elements. By that also, we can limit the damage effects in general in such a way. The very basic aim of structural design is to provide safety and to have a serviceable or functional structure which is durable in that design or life or service life of the structure. Of course, it goes into even make it more appealing, economical. These are some of the basic aim of structure design in generic form. So you can see this picture. This is one of the prototype structure in our university, in my university, and we try to study as much as possible all the structural systems like linear parts of structures, like beams and columns using bamboo, and the surface structure like deck and floor systems have been placed in the study. So in general, the provision of these structure systems within the basic aim of safety, serviceability, and durability should be placed in the practice of structural design. Of course, we have different conceptual approach of structural design. For example, this is one of the example. While we employ a design process, computing the stresses and providing or proportioning the sections starts by understanding the load effects on that structure and properly addressing the requirements would be the very important part of the design process. Of course, it is an input, a process and output kind of activity. And finally, that designed section or member should be under the provided compliance. So then material specifications could be drawn from a design output, detailed cross sections and member size would be drawn in as per the design output. Of course, it is very trial and error kind of process. You can see these pictures of vertical element, horizontal elements, and aerial element, even the connection between the vertical and the foundation system. You can see a third picture. So both the load effects and requirements through proportioning, meeting the requirements, would have a process, and then finally optimum or appropriate cross-section would be detailed. The conventional approach of designing structures follows from conceptual design, setting structural systems, and then modeling analysis would provide the initial members and finding appropriate responses. And finally, after multiple iterations, members could be designed and should be within the acceptable compliance requirements, and then detailing would proceed. Okay, this is the very conventional approach of designing structures. That's a very important component when we employ structural design approach to find a structure which is functional, which is durable, deals on the two effects. The first one is load effect, and the second one is strength of a material. So taking the load effects, which is characteristic in its effect, of course, that should be, for example, 5% of the probability of exceeding that characteristic load effect should be within this range. When we take the strength effect or strength behavior, of course, 95% of the strength has been counted in the investigation should exceed the characteristic strength value, which in the reverse direction, 5% should be below that characteristic strength value. So this is a very basic understanding of how we could understand the load effect with the strength to know the response of structural system made of any kind of material. Coming to the philosophies of structural design, there are certain bases of design concepts. Of course, these concepts start on a very well articulated concepts of how we could reach into an optimum strength provision, how we could reach into a very serviceable structure and durable structure. And these are the four design concepts which bases structural design philosophy. Some philosophies developed based on the calculations and testing. Of course, this is a very important one, which we can get an exact approach to determine the strength, serviceability, and durability of that specific material or system. The other part is experience from previous generations, which depends on the locality, the context, and based on the oral records or written records. By that, from previous generations, we can get the concepts, how we could make it strong, make it serviceable, make it durable, that structure we are supposed to make it realized. And the third one is reports on evaluations of happenings. It is if there is happening in the past, and if reports have been recorded, based on that, studies or reports would suggest the extent of the stringes, serviceability, and durability. Of course, the emerging concepts can also be part of the basis to develop structural design philosophies. These philosophies will mainly depend on the mechanics of materials and load effects or extents and system responses. Both these items would help to understand the very basic understandings of philosophical approach to reach into which method, which approach would help to really capture the response of that material, that structural system. Of course, philosophies, theories, models, and frameworks in general would provide an input to code of practices. Of course, code of practices are very important in structural design to have a direction, to have a compliance requirements, to really understand the provisions toward these compliances. From our study, through literature review, and then with an expert interview or Delphi survey, we found these three philosophies are based on load versus strength relationship, permissible stress design, load factor design, and limit state design. These are basically depends on the relation between the load effect with the strengths of that material or that structure system. And the emerging design philosophies, which are emerging, evolving these days. These are also three in number: capacity-based design, performance-based design, and risk-based design. This each philosophy depends on special attributes. For example, we take capacity-based design. It deals on the section capacity. Then whatever the material, that section capacity based philosophy would indicate that only the section matters, and the section with demand relationship is dealt on that philosophy. Of course, the others also deals on performance and risk systems. Well, we try to identify which parameters are very key in the development of structural design philosophies. There are 6 so far that exist in this body of knowledge in the structural engineering. They have their own attributes. For example, working stress design is based on the service load effect, so that safety could be considered within that load. So each philosophies have a particular attributes in the design process. So we try to categorize based on the experts' feedback. So the first category is force-based parameter, which deals on load and load behavior, material type, material behavior, strength, and the like. So these are related into load versus strength relationships. These are some of the categories. And the other category is displacement-based parameter, which primarily addresses deformation nature or damageability, performance, durability. These are under this category. Of course, there have been 16 key parameters been selected from or suggested by experts, and these parameters have been rated to know which one is significant among the selected parameters to devise very suitable structure design philosophy. For example, we take in the first category, force-based category. Within the category, material type, properties, and behavior are a very significant key parameter when it comes to force-based approach. Whereas when we come to displacement-based approach, still displacement is the highly significant parameter to devise structure design philosophy. These two parameters are very significant across the category, between force-based category and displacement-based category. Again, within the category of functionality-based parameter, of course, itself functionality. The function itself is a significant one within the category, whereas it is very less impact or less significant across the category. So from the finding, we can state that displacement, material behavior, and functionality are the key parameters to devise the structure design philosophy when it comes to within the category. Okay, even load behavior, failure mode, and method of construction are also second to that group of parameters, which has an impact in the devising the structure design philosophy. When we say which parameters are highly significant across the category, displacement is the first one, material behavior is the second, and these are also some of the parameters that significantly relevant in devising structure design philosophy. As you can see, displacement, failure modes, damageability are a displacement-based approach, which is, you can see the governing one goes into displacement-based approach. Of course, this tells us there is a significant relationship between a force-based design approach in terms of material behavior and design philosophy, whereas there is no any significant relationship when we take this study of displacement-based approach between material properties and design philosophy. Of course, this needs further investigation, but experts, scientists suggest that using a Delphi method, displacement-based approach could be a potential philosophy to even non-conventional materials. When it comes to bamboo structure design, yes, the practice of bamboo structures in terms of designing, we take even the Eastern Africa region, even my country, Ethiopia, it's still an infant stage because there is untapped discussion in discourses concerning the characterization of materials of different species. Of course, literature suggests that even engineered structural bamboo product could be one of the potential toward this carrying loads for a function. Okay, but still the process of structural design of bamboo is on the infant stage. Yeah, bamboo is an abundance. Taking Ethiopia as a case, it's having a very large resource here in Ethiopia. And the nature of bamboo by itself is flexible and it's sustainable. So as an alternative material, bamboo could be a potential resource to use as a structural material. Taking its lightweightness and the strength to weight ratio is one of an excellent behavior. These characteristics would help us to consider that material into a structural system. For example, if we take diameter and the moisture content and density of the single location configuration of that physical nature, you can see 8 kilonewton per meter cube weight is measured in strings or in the physical nature of the Sidama location bamboo, which is a highland bamboo. So you can see which is light within that diameter of external and thickness. We can get light material. Because bamboo has desirable mechanical properties, we try to understand the behavior of this the same location bamboo and try to understand its behavior towards the compression springs, tension springs, and modulus of elasticity. We have got quite an interesting behavior. If we take compression, it's about 23 megapascal strengths could be attained in this Sidama location, which is specific to that region, the Hagar Salam location. So 23 megapascal could be attained. Again, tension strength is about 65 megapascal. Of course, this is almost 3 times of the compression, which is very interesting. While modulus of elasticity characteristics value is about 3 gigapascal. So, of course, it has its own limitations, its own benefits. But when we see these mechanical behaviors, bamboo is one of the potential sustainable structural material. And coming to the code of practice, which helps to facilitate the design process of structures, especially bamboo structures, is the code of practice. Of course, a standard becomes a code of practice when it is implemented in public agencies to legally enforceability. So by that, of course, unless we have such code of practices for bamboo structures, would be a challenge to design structural systems using bamboo. These are some of the code of practice in the world: Colombian, Chinese, Ecuadorian, Indian, and Peru. So these are some of code books. Not exactly a structural design of bamboo, but it is related into that concept. We need to establish an approach how to design bamboo structures. We take our context. We need to have material characteristics, full understanding. Of course, the assessment of structural material strength is basic in the design code of practice. Unless we get a defined strengths classes through bamboo structural grading, it will be difficult to design even a single truss structure. And again, it's known that apart from conventional materials, bamboo has a great deal of variability, so that we need to take care of that variability in terms of defining its grading. Even if we take the height or the length of a bamboo, it has its own variability in the node distance, internode distance, even the straightness, the taperness. These are all parameters which are very critical while we consider as a structural element to withstand an impact. One of the duties that should be followed before implementing code of practice development is setting bamboo structure grading. So a previous approach was doing strength and stiffness competitions, but still due to the great deal of variability of bamboo material, multiple combinations of, for example, diameter, taperness, straightness should be included in the bamboo structure grading, so that we can know the nature of that material. So to conclude my presentation, would like to pinpoint some of the findings from our study. So the recent philosophy, which is employed in the code of practice some of the countries, is quite similar to timber structures, which is a limit state design. But still within that understanding, we need to investigate further impacts of like displacement-based parameters of emerging philosophies, which is, for example, performance-based, displacement-based, capacity-based, and risk-based philosophies. In this research, we saw that material type, properties, and behavior are based on the force-based categories, which is a key parameter. Of course, it goes into the concept of limit state design, which is load versus strength behavior. So displacement is based approach. Of course, not only displacement, failure modes, mechanisms. These are some of displacement-based category parameters. And then considering this philosophy could also be an input to design bamboo structures. So we can draw some future remarks, since it is a desk-based and a survey-based research. A complete investigation of bamboo material for each species is needed, and further studies on emerging structural design philosophies should be placed in the future study, since it has an indication to implement emerging philosophies in the design practice. And when we say displacement-based structural design approach, of course, this is one of the feedback that we receive from experts. Could be one of the potential approach to devise structural design philosophy, so that we can get clear conceptualization and formulation of concepts together with the design models to give a feedback to code of practices. Of course, philosophies would help to generate theoretical models and concepts, and then would help to develop a code of practice. So these theoretical models should be further investigated in terms of how we could use philosophies, structural design philosophies for bamboo structures design. Again, the code of practice of region is highly important. The development of this code is really important toward this utilization of bamboo as a structural material. Thank you very much. So this presentation and this discussion been taken from 3 projects. The first two paper is published, and the third one is on the way. Thank you very much.
Okay, thank you very much for your excellent presentation. So Professor Leo shared us the knowledge about approaches and codes for structural design of bamboo. So what kind of the process we can use, and what's kind of the different philosophies such as capacity-based design, performance-based design, and risk-based design. So as you said, bamboo structural design is still in infant stage in many countries. So we still need efforts to carry out more research and discussion on it. So if any participant has any question, you can type your question there, and we will have the Q&A after the 3 presentations. So let's welcome Professor Ugang Sangwa. So I think you have re-logging in. Are you there?
Yes, I'm with you.
Okay. So please open your PPT. Okay, thank you. So you can start.
Thank you very much.
Okay, perfect.
Like you earlier said, I am.
So you can click the button and make it expanded. Yes. Okay. Thank you.
Yeah, thank you. Like you rightly said, my name is Olukayode Yakin Ogunsanwo. I'm a professor of forest product utilization at the Department of Forest Production and Products, Faculty of Renewable Natural Resources, University of Ibadan, Nigeria. I am very happy to be here to present this paper, which talks about sustainable development of finger-jointed bamboo glulam, which is meant for poverty alleviation in Nigeria. The study is motivated by the fact that bamboo is found in abundance in Nigeria and so many West African countries, especially Nigeria. And we find out that people suffer in the midst of plenty. And there is need for us to bring this important forest products into focus by trying to bring out a product that can be leveraged upon by those who live within the bamboo growing communities in the area to develop a technology that is simple enough for people living in those rural communities, particularly in the forest enclave, the enclave dwellers, to leverage upon and develop themselves and improve on their livelihood. So bamboo itself is considered as the fastest growing woody plant. That is, it takes about 5 to 6 months to reach mature height. And then the maturity of bamboo is between 3 to 5 years, a little bit more than 5 years in some cases. And then it has also been reported that the biomass productivity of bamboo is extremely high, reaching about 500 centimeter cube in terms of their cell wall substances per day, resulting in a total of about 0.1 meter cube for the entire comb for such species like Guadua angustifolia. Now, We also found out that bamboo-based panels and boards in that growth rate and hence a higher rate of biomass accumulation provides an opportunity for larger volumes per hectare, thus giving room for faster regeneration, which promotes sustainable forest management. One of the key issues here is found in the strength properties of bamboo. We discovered that the specific trends in some of the researches that were carried out in the past, that the specific strength of bamboo, which gives relationship between weight and then density of bamboo, is higher than some tropical choice species like Caya senegalensis, Mansonia altissima, Milicia excelsa. These species are sought after. And in fact, some of the reasons why we have a high rate of deforestation, because people go into the forest to look for these species. And then as this is discovered in our research, Ogunsanwo and Tazib in 2010. Motivated by the result of this research, we try to look at the attributes that have stimulated the use of bamboo for various applications in many parts of the world, especially in Asia, which is spreading fast across the globe. Now, because bamboo is a relatively small woody material, there is need for us to do what we call recombination method in producing bamboo lamination. We all know that in composite materials, we have the process of splitting first. That is, we first of all split and then we recombine. So fortive bamboo lamination therefore requires that there is proper blending among the laminate members such that shear forces that is acting to disengage the laminate members may be resisted. So what we're trying to say here is that for us to have good boards of bamboo that can and have
So maybe there are some kind of the problems for internet. So Professor, I'm sorry for this problem. I don't know whether Jen is online. Mr. Jan Herrick Power.
Yes, please. Hello. Good afternoon.
Okay. Okay. I could have an introduction of your profile and introduce you to deliver so next presentation. So Jan Herrick Power is a German engineer and project manager with over 18 years of experience in the renewable energy sector. Focusing on solar energy, he holds a master's degree in civil engineering and is certified in various renewable energy and energy efficiency disciplines, including in European energy management and battery energy storage expertise. Power has led numerous solar PV projects across Germany and Sub-Saharan Africa, specializing in engineering, procurement, and commissioning for commercial and industrial clients. As the head of Solar, he oversees project design, implementation, and training. Recently, Power expanded his expertise to bamboo construction, where he applies his carpentry skills in sustainable building projects. He has extensive experience in development cooperation, particularly through projects with GRGs in Ghana. So, welcome, Jen.
Shall I start? Yeah, shall I share my screen?
Yeah, but Professor Usuyawa is back, Kebe.
All right. Yeah.
Okay. So, Professor, sorry.
Continue your presentation. We cannot hear you, or at least I cannot hear you.
Okay, the Zoom is broken. Sorry for the internet problem today. So, okay, so Professor Ogansambo, could you hear us? No? Jen? So
Yes, please. Yeah.
okay, Jen, I think you can start.
Okay. All right. Then. All right. So I should be online now, or maybe that you can see my face. No, that's
we can see your slides and cannot see your face.
Now good.
Right now, okay.
Here we are.
So welcome.
Okay. Thank you very much. So
okay, you can start.
Okay, I will do that. So thank you very much for your introduction of mine. In shorter words, you find it here, but I don't want to repeat myself or repeat you. So what just happened with our professor, I hope it won't happen with me. I speak now from Ghana. I'm in Kumasi right now. We have terrible network problems recently, and so we all have to pray that that it goes well. Yeah, so let me start my presentation, and it is more from the practical point of view. I want to talk about managing curved bamboo, and the reason for that is that usually it is considered being not appropriate enough for bamboo constructions, At the same time, it is easily to be accessed here in tropical Africa, if to say so. And that's why I thought it's important to talk about that and see or show how we deal in my carpentry, in my workshop, how we deal with that. So this is the little agenda. I don't want to bore you with that. And instead of that, go straight into that. Yeah, so for this kind of Bambusa vulgaris, we don't plantation that. It is normally harvested from the wild, from the natural clumps. Still, the normal setup of the common Ghanaian, I don't know about the other West African or African countries, it's considered being the poor man's timber. And me starting with the bamboo, it was coming from a course from Asia, from Bali. I thought without Guadua, without INBAR, there's no way. But yeah, so that is maybe shows a bit of my mindset as it was. This means as well there's no market for straight construction bamboo, I would say yet. That means as well that we hardly have plantations with INBAR and Guadua currently at hand. At the same time, the local bamboo, you can find it at every timber market. It is affordable. And since you can find it everywhere, it is easy to access. So, so if we now could say there's a good use, if we could conclude later that there's a good construction value for the Bambusa vulgaris, which is quite, yeah, which has many varieties as well. We have direct access to an excellent and low-cost building material. So now I went to a company. They did a survey, and this is a survey. So they took bamboos from all over Ghana, and now I wanted to know about the properties. And here we could find, for example, we can find one which has a diameter of 13.5 and the wall thickness 2.5 centimeters. Of course, this one is depending on is it rather lower at the culm or is it rather up? But still, it's if we take the lower parts from a let's say 10-meter bamboo, well, we have a strong we have a strong building material, and of course we have curved and straight ones. I will come to that later. So here the conclusion would be, well, we have fantastic Bambusa vulgaris or bamboos here in Ghana. Just have to know to find it. So this one here would be one which is from the western place or western region. So my recommendation is, if you well, first of all, you have to choose your bamboos according to your project requirements. So if you need 2,000 poles for your project, you will have only few where you need the perfect straightness and 13, 10 or 11, 12 diameter. So so these ones, the ones which you need particularly, this one you have to handpick from the market. That's at least how we do it. And we are handpicking, which means we go there and sort most of them out. And of course, we pay a higher price for the poles we are taking then. Up to now, we are allowed to do that. So let's see, probably a question of money as well. So yeah, so how does it appear? Mainly, mostly in the natural bamboo that we have. So here are two pictures. One is taken from Wikipedia, the other one from ourselves. So when we harvested last year some bamboo, so we can see that the middle is straight, and we can see that the sides are being curved. We can put that more into a picture, and we could say, okay, 10 to 20% of a clump, sorry, maybe fairly straight, and the other ones have more or less curves. And there's a second pattern that we experience, and that is what you can see on the right-hand side. That columns have the tendency to, to grow right, left, right, left. So now, what are we going to do with it? Can we use it? What's the further tasks? So I found out there are 7 different ways how we can manage the curves, and these are the 7s. And now let's go through it. So we could say maybe the whole column is curved, but parts of it may be straight, or at least straight enough. So it's a question of having a proper look at the column and cut it and take the straight parts out. The other one is for the one on the right-hand side. At least we would have a straight part which has 30 to 40 centimeters of straightness. And the other one is cutting. So if we have a curved bamboo, we could say we are making instead of using the full column, we could say we take a half cut. So if we now rectangular to the bending, we could slice it. So we could split it. The bamboo is losing its rigidness, at least in this particular direction. But if you look at it, more or less, if you look at it from the front, you could say, it's straight from the, it's going down, or it's if this one, or this one now is straight. So and it is at the same time it is flexible in this direction, but stiff in this direction. So that is and that is a way how you can strategize that. There's another way of cutting which I like quite well, and this is I call it the segmented cut. You see it at the down at the right, and then you do 2 cuts in parallel, and then you have a middle part as well. And these outer parts, they perfectly fit together, so you can straighten it and then do kind of plier construction or so. You can see that on the picture that you below. That's what if we have some functional buildings or so, we use the splitted bamboo and put something in between. The next is we can use the bamboos, or we can use bamboo structures which allow curves. So, and this is what we mostly do. We use splits and we use half cuts. And here I want to show you examples. So this is what I would call a Ghana bamboo yurt. This is it's a parabolic tower, and here we used half cuts actually. We cut it into 2, and then what you see on the right-hand side, where we close the walls, this is a kind of weaving technique out of splits as well. And here as well, in both cases, we don't need what we found on the market. Yeah, another example for splits that we have here. Of course, some for the ones which are radial here, they are fairly straight, but the rest ones is almost any bamboo, I would say, would do. And here another one that we had where straightness is relative, if to say so. The next strategy would be that you work with the curves. So we need not to say only straight poles are let's say fine or beautiful. I mean it comes with a structural impact as well. I think my successor, he said it's about displacement. So. But here, these are things where we work with it. It's, for example, with the staircase, we ran out of the full straight ones. So we had some were a little bit curved. So this, so I'm talking about the sides of the staircase here, so where we had to slice in the kind of small columns for the steps. And the takeaway here was it is possible, it works. I personally find that more beautiful if you have this kind of lively curves in it. But the downside is it takes more time and it's more prone to folds. But still, still it works. And here we had, I think we had to two of those we had to do we had to do it again. But apart from that, it took a bit longer, but we didn't have any further waste. So here for the same project, here you can see that we put in some kind of platform, and on this platform we placed a floor, and because this bamboo goes a little bit up and down, we try to find something which levelizes it, wedges underneath, and then it worked quite well. And yeah, that is what came out of it. It was a playhouse for a kindergarten. Client wanted to have it white, not the golden bamboo, but yeah, that's how it is. Here in the front, the balustrade is weaving technique as well, and yeah. All right, yeah, and then another one is you straighten the bamboo, the splits. So here you see our miter saw. You do a parallel cut on this circular saw on both sides, and then something. Just an example what we did out of it. We have this little stool, which is quite common in Ghana. I don't know how much about Nigeria or the others. This is very common. Any household has it, and this is where the people come and sit together. Yeah, and then another one is outsource the problem. Why not? So here we are lucky enough, not too far from our place, to have a little factory which works for exporting. They're called Bamboo Products Limited. They are located in Tema, and they do slats mostly. We can have splitted bamboos as well, and what so. Work in progress, we're on it. So what we do out of this slats, for example, is this bed frame that you can see right now. And what we tried as well is this chair, which we have here on the right-hand side. Another way of dealing with it is, well, I mean, I mentioned that before, that if it's short enough and you have a node length of 30 to 40 centimeters, then you can you only use this 30 to 40 centimeters. What I learned from Moses from Ghana as well, we went with the team. We went there for learning how to weave bamboo. When you slice it thin enough, you can start to sew it as a tailor, and that's his product here. And he can not only the small, he can do way bigger things like that. And two other, excuse me if they are simple examples, but just to show you, there are so many ways and so many things that you can do with bamboo. So the upper one is a curtain stick holder. I think I need not to explain how it works. And below is where we, have hangers where we can put whatever clothes and jackets or hats onto it. Yeah, now finally, my seventh way is, what if curves were seen more beautiful than straightness? Well, then we have arrived in the modern contemporary architecture language. So you hardly find straight or bamboo columns, poles, columns in those structures. You rather find splits. You see it here. We have leady bundles, and the rest is laminated slats. So this one is a picture that I took from Bamboo Indah, which is a restaurant in Bali done by Ibuku. It's the sunset bar. And if you look at this, there's not one column, not one pole. We have some rub, which you can find here, a special technique. For this one here, this is a laminated, these are laminated slats. Everything that you see here is either laminated slats or the round ones. This is what they call lidi bundles. So you have sticks of bamboo that you put together into a bundle. You have to wrap it every, I don't know, 30, 40, 50 centimeters. But this one is free in the way you can bend it. So and this means with this type of constructions, we are out of this constraint of strictly straight construction bamboo. And one of my conclusions here would be that, yes, Bambusa vulgaris, if handpicked, if mature, is an adequate source for modern bamboo architecture. So now, if we look into that, where are we going to? We put out our Rhino software with a grasshopper, and we start. And we are not shy to do whatever design and construct here later. I would like to mention that this one here is done in cooperation with a friend, and his name is Mauro Buffa. All right, I'm coming to the end of my short presentation. Well, we could say that bamboo, straight bamboo, is especially useful for the columns. We can pick these few columns. We can pick them from the local market. For larger projects, I suggest that we go to the preferred places in Ghana, where we have the, for example, bamboos with the thick walls, or those with the big diameters, and we shall harvest that ourselves. We shouldn't leave that to others. But I mean, anyone a little bit longer in the business will tell you the same. There's a reason why we have curved bamboo, and this is because it comes from a non-managed clump. So vice versa, if we start managing the clump, cutting out some of the shoots to bring a bit air, I would call it, into the clump, the bamboo is not curving anymore, but has enough room to grow straightly. And I would like to say that Bambusa vulgaris is the most, because it's indigenous here, is the most adapted species for the many different local climates and soils. And if you introduce new species, you may find out that it's not as, the properties are not as good as you would have expected it. I wouldn't look too far to the east or to the west, to South America or to Asia. I think that what we could do as well, we could start managing properly the natural bamboo clumps in those areas where, in the west, where we have the preferred bamboo properties, which would be mostly in the western region, which is the tropical region, tropical rainforest that we have left here in Ghana. So this was on my 7 strategies how to deal with the straightness or the curves on bamboo. I want to add something, since I was introduced as a solar engineer, and we have the main topic of sustainability. We run our carpentry here fully on solar. We are off-grid since 1 year. And our system is not even big. We have a system which consists of 5.5 kilowatt of modules. Our inverter the same. We have 10 kilowatt hours of usable battery. And we don't have only the workshop. We are 4 people living here in our house, or in our, you see, it's a little assembly. And so the conclusion or the advantage or the the possibility, the chance that we have here with the bamboo as well, since it's rather crafty or rather handcrafted than heavy machinery needed. We could say, or I would say, and I'm a little bit proud of it, to say that we are here fully on solar and we are not using conventional power. Yeah, so that was it. Thank you very much for your interest in our presentation. I want to introduce my team as well. So we have on the left, we have Johnson, Ajay. In the middle, we have Benjamin, Ajay. They are not brothers. I guess you can see it. Ajay is pretty common, this name. And we have a dog as well. If you want to get in contact, this is my WhatsApp number, and the other one is my email. So thank you very much. And yeah, back to Liu.
Okay, thank you very much, Jan. I think you deliver a really interesting presentation. You not only shared how to deal with curved bamboo, shared 7 ways you conclude for us. We can use straight curves, straight them directly, or cut into 2 parts, or slide it into make the fashion shopping bag. And actually, for some kind of the small diameter bamboo species, I think architects, they prefer to use curves into special shapes. This is the unique characteristic for bamboo compared to other timber structures. So I think Edwin must be very interested in how to combine the solar system, use renewable energy with bamboo. So thank you very much again. And let's back to Professor Ogang Sanwa. You can open your PPT. We can continue.
Thank you.
Okay.
Am I audible now?
Yes, we can see your slide.
Okay. Now,
Okay. Please.
Thank you. I will. I'm sorry for the break in transmission, network issues. We'll continue now, and I'll try to be fast so that we can move as fast as we can. So we were discussing the importance of bamboo in terms of its ability to grow fast, and then its acceptability in terms of the specific strengths. And in table 1 here, we can see the subspecies that are in high demand in densities. There are modulus of rupture, modulus of inertia, and then the maximum compressive strengths parallel to grain. We can see species like Mislicia excelsa, Kaya senegalensis, Mansonia altissima, and then we also have Bambusa vulgaris. We'll see from this table that Bambusa vulgaris has specific strength of 100, which is comparable to some sought-after species, meaning that when we prepare laminations of Bambusa vulgaris, it will compare very favorably with species that are in high demand and that are being sought after, leading to destruction of forest resources and the uncontrollable deforestation in tropical Africa. In Nigeria and other West African countries where timber resources are dwindling, as we have said earlier, due to uncontrolled deforestation, high demand for wood, And where necessary prerequisites and the institutional framework for regeneration are not in place, there is need for us in Africa, particularly in West Africa, where bamboo is in abundance, to make utilization of viable alternatives such as bamboo, which has great potential to address problem of wood shortage with minimal negative to the environment should be part of our development plans. In African countries with abundant bamboo distribution, could therefore leverage on the great potentials inherent in bamboo with a view to developing bamboo-based lamination technology that is capable of lifting the poor people in bamboo-growing communities out of poverty. And this is achievable through engagement in production and trade in bamboo lamination ventures. If we look at figure 1, we have, it shows bamboo distribution in Nigeria. We have divided the country into 4 different locations based on bamboo availability. We have bamboo in abundance in the western part of Nigeria and some locations in the Niger Delta region. And occasionally, we'll find them in the Guinea Savannah regions, and then they are very rare in the Sahel Savannah and occasionally occur in the northern Guinea Savannah. So this, the motivation is really in the southwestern and the Niger Delta regions of Nigeria where bamboo is in abundance. That is really our focus. And in realizing the potentials of bamboo because of what we have carried out in the past, like in 2007, Ogunsanwo et al. In 2010, Ogunsanwo and Tessive. 2013, Ogunsanwo and Erakumen, Olajide and Ogunsanwo 2013, and Ogunsanwo et al. 2014. From what we have found out, we now sought grants to do a comprehensive study on bamboo distribution in Nigeria and also to utilize bamboo in producing a glue lamp. We adopted the bamboo growing forest enclaves in Nigeria and other West African countries. And the intention is that the output that is coming out of this study will form community-based bamboo cottage industry that is going to be employed in the resource-poor areas within the African community. We took specimens from 4 different locations, 2 in the southern Guinea Savannah areas of Nigeria, and then 2 sites were also selected in within the southwestern Nigeria where bamboo is in abundance. And these are some of my colleagues that were involved in the bamboo survey and harvesting on the field here, somewhere in Osun State, Nigeria, where we were selecting bamboo to be harvested. On the basis of our findings, you know, bamboo grows naturally here. And because people grow them in their farms and they occur naturally in farm fallows, we try to find out the age of those because they are familiar with the ages. So 5 to 6 years old bamboo was selected. And then we took bamboo based on our preliminary study. We took 1.5 meters only from the base we harvested to ensure that we have enough thickness along the base to work with. During the methodology, combs were sewn through the nose to form sections of 5 to 50 cm long, which were further split into 4 equal strips using the circular saw. Test specimens were also cut from the middle of the strips for density and strength property evaluations. And for density, we took 8 combs from each site for samples were, the first samples were obtained for each strip to give a total of 32 strips. Each strip was then partitioned into 6 layers from the inner to the back to give a total of 192 test specimens. Lamination procedure involves the production of 10 by 30 by 500 mm were used to produce a laminated board. Those laminate members were combined in various forms to form the lamination bamboo board of 30 by 80 by 500 cm using the PVA with press under normal room temperature. Balls of this bamboo were trimmed to standard specimen of about 20 by 20 by 400 and allowed to condition for 2 days prior to the test. And from what we observed, these samples in plate 3A and 3B were the results. Samples of bamboo glulam are in plate A, while plate B gives us a finger-jointed glulam of bamboo vulgaris. You can see the line of the finger joints on plate B. Wood density was determined using a dimension of 20 by 25 by 500, and we're taken at 12% moisture content. And the sample preparation, we made sure that sample preparation followed methods and general requirements for physical and mechanical tests recommended by international standards. Mechanical properties of glulam were tested. The produced bamboo lamellae from the study stands were glued to form boards, as explained earlier. Boards were placed in condition room for 20 and 65 relative humidity, that is 20 degrees Celsius, and at relative humidity of 65 to achieve equilibrium moisture content at that level. The balls were therefore finger jointed under industrial condition. The finger joints had a length, this is the specification of the finger joints, 10 mm, 0.6 mm tip, and 3.8 mm pitch at an angle of 22 degrees. The lamellar fingers were glued in accordance with technical recommendation provided by the manufacturer of the glue, because we thought we didn't buy glue from the market. This glue was produced specifically for that particular exercise. In the proportion that is slated here, melanin, urea, formaldehyde, MUF glue system at ratio of 1:247 to 256 of adhesives and hardener. Gluability test was done by putting the bamboo strips in the machine for shear resistance along the glue line. Samples were prepared in accordance with the standard procedure. In doing this, 3 types of specimen were produced from 2 density classes. The lighter inner part, which is coded as S, and then the denser outer putting part, which is coded as H. Samples were therefore glued in 3 combinations. That is, we have HH, that is outer back and outer back. Then we also have SS, that is lighter inner back and inner back. And then you have SH or HS, which is outer back and inner back. Using the special product of Casco Nobel. And the glue was done at the ratio, at a rate of 200 grams per meter squared on both surfaces and pressed at 2 kg per cm square using Shimazu model UTM. This was done for 60 minutes under room temperature. The bonding procedure, in the bonding procedure, test specimens were allowed to cure for 24 hours, after which they were tested for strength along the glow line using the Shimazu model UTM. And load at failure were recorded, and the corresponding computer readings were taken directly from the machine. Key findings in this research is that we have the density variations according to the layers. Layer 6, being close to the outer coating, had the highest densities for all the 4 sites. And then layer 1, the lowest for all the inner sites. It is important to note that in density distribution, we have plot B, which is located in one of the southern moist forests, particularly in Olodo, Ibadan, Oyo State, Nigeria, are the highest in terms of density of bamboo, while the one taken from Jericho in Ibadan are the lowest bamboo density, as seen in figure 3. Now, in terms of shear strength along the glow line, this is an attempt to pull bamboo apart along the glow line. We could see from this table that HH, that is back-to-back, bamboo lamination had 10 Newton per mm square. For SS, which is the lowest, 8.65, and then you have 9.54 for H and S. The expectation in this result is that we were expecting that HH is going to have the lowest, the highest as expected. No, we are expecting that SS should have the highest, because according to what we found out in our anatomical studies, when we try to cut the bamboo along the glue line, the test specimen along the glue line, we found that in plate 4, we found from A, look at the distance from A to B. Distance from A to B is giving an indication that we have A to B as the 2 surfaces of the H and H specimen. And then between A and B, we have the glue that is loaded within the surface, within the interface. If we look at the figure for SS, which is A1 to A, and then B1 to B. The distance B1 to B is the distance for glue accumulation. That is, the glue was inserted into the bamboo surface. And as you also find in B to B1, that is glue absorption into the wood. What happened, what played out was that in the case of S and S, failure did not occur along the glue line. It didn't occur at the interface. It occurred right in the bamboo, in the inner side of the bamboo, outside the glue line, meaning that it was difficult for failure to occur in that middle, and whereas it occurred outside the glue line, it was the bond in between the 2 surfaces were too strong to such an extent that it couldn't be broken, whereas it was broken so failure occur where there's no glue line, and that's why you have a lower value in SS, not as a result of absorption of glue. We look at strength properties of a finger jointed board made from glulam. The result in page table 2 is giving us, for instance, the samples were obtained from Flynn, where 166 Newton per mm square, and then 73.4 in the finger jointed, meaning that the finger jointed bamboo is weaker, but it gives opportunity for unlimited length when we are trying to use bamboo for wall cladding, for instance. So it gives unlimited length, and so that we can manipulate it to a very large, a very long length in terms of utilization, because we are trying to prepare people to produce bamboo that is going to be meaningful and useful in the market. So from our findings in conclusion, it seems that the location, because we have taken bamboo from different locations did not play any practical importance when the bamboo glue boards were manufactured. And the implication of this is that we have wide area to collect bamboo in terms of utilization in eventual case that the cottage industry of bamboo is established in the study area. So this
It seems Professor Ogansaba is stuck.
significant differences were found among the bamboo density. Party is that such durability and budget, meaning that we and adaptable in rural areas of Nigeria, because this lamination process does not require sophisticated equipment. Can you hear me? Can you hear me?
Yes, I
Can
can
you
hear
now?
you.
Yeah, we can.
So,
Can you hear me now?
Yes.
Yes. Okay, now we'll talk about policy recommendation and other stakeholders should take advantage of the simple technology involved in bamboo lamination to develop a bamboo-based industrial hub in rural communities where bamboo stands are in abundance. And we also recommend that efforts should be made to transfer this bamboo-based novel technology to cottage level among rural poor communities in areas of abundance in selected African countries. So this could be done through hands-on training and then training of trainers programs in order to reach wider participants across growing communities in Nigeria and in Africa.
Okay, thank you for your sharing to us about how to use local bamboo species, bambusa, to prepare the samples of laminated boards and your findings for their mechanical properties. I think it's very important for African countries to figure out engineered bamboo products in the future. So let me hand over to Dr. Edwin for Q&A. We already received several questions from participants.
Okay.
Edwin?
Thank you. Yeah, I will be quick because we only have 10 minutes. Just taking the advantage I have the word, if I can have the 3 speakers open their cameras and mics, we can do this faster, please. And I would like to start with Professor Leule. Very interesting, the framework you were showing. I was wondering if you had the opportunity already to analyze construction techniques from Ethiopia using this matrix that you were working in terms of design and appropriateness, and see what are the potentials that are there in the vernacular architecture from and construction techniques from Ethiopia.
Thank you, Edwin. Still in Ethiopia, we have a great interest to use bamboo as an alternative material because we have very expensive conventional materials for different structural systems. I believe if we drew with investigations of a material behavior, even our government has an intention to use bamboo as a conventional material in a way to substitute some of the very highly expensive materials. So there is a potential, but still with a challenge.
Okay, thank you. I have a question for Jan, and before that, a remark from Professor Ken Harris, and it's related to the work that Professor Jonas Hauptmann is doing at Virginia Tech, looking at minimal engineer, minimal process bamboo. That's similar to the work Jan was presenting. So it's also very interesting to see how different people come with very similar ideas. And the question, Jan, was on if you have standards on detailing these connections, especially in staircase elements.
Well, this is from normal carpentry. I don't have it at hand, like in my head. So there's a certain there are two rules you have to apply, and this is more or less you have the height of the step, and you have the length of the step as well, and this one has to be in a certain relationship to each other to have a smooth walking either up or either down, and this one is easily found. I mean, I had to recall that myself after being, my carpentry has been something like 30 years ago. So I had to recall that, and how do you do that these days? You hop on Google, you hop on ChatGPT, and you ask for that. So so that was one thing. I mean, as always, you have to figure it out a little bit. So what is the height of your platform? So the overall that you have to you want to go up, and what always helps is putting up a drawing in a cut software. We use LibreCut, which is open source. So we are not, so we are, it's again, like bamboo, it's accessible to the public, and drawing always tells you so much, tells you everything you're doing wrong, and you have to correct it, and that's how we did it. So, and then we print it out, we put the measurements, and then I give it to, in this case, it was Johnson who did it. And well, then he has to wrap his head and his fingers around it. So yeah, that's the best I can say for now.
Okay. There's also a question related to Bambusa vulgaris. To this moment, you're kind of the champion of vulgaris, because many people will just say no, don't use that. But I think that this commonalities with other clumping species, like now I have the Filipino name. The Bambusa bumayana has very similar behavior with the. So what's your taking now with vulgaris as is a species that can be used for lamination, is a species that we can also use in construction. Can we use that extreme bend to do these very difficult elements when you start with a straight moso bamboo and you have to curb it is a huge effort. What's your take in there with the Bambusa vulgaris?
Well, I mean, it is pretty simple. So you get a request, do this or do that for us, and then you start with it. So if we now have the request that we need to have a straight bamboo culm over 20 meters, we're going to have a problem. But you have to think of how can we reach the same properties with different means. So instead of using one culm, can we do a double culm? Can we use? We have one culm? Can we enforce it somehow by putting additional culms where it may break? So, for example, in the middle, it has the tendency to buckle. So if you have a column and you press it from both sides, it's going to somewhere in the middle. So if you say, okay, we're going to make a bandage of split bamboos or whatever we read. So these are the things how I would approach that. And if you look at for example, if you have a public building and you need to have your structural approval for the building department, there's hardly a civil engineer who's going to calculate that. So the way you do it is you build it and then you put all the loads on it as required, and then you check if it keeps or it doesn't. So I would say we are young in this matter here especially in West Africa. It's more developed in, I guess, Asia. Bali is the most advanced place, apart from Colombia, probably Mexico. And look, I haven't a clue of that. It's just a little bit my impression. So that's how I would go about it. And talking, for example, about Ghana, we don't have a major bamboo project yet. There are every now and then someone is coming, project, and then it disappears again. So, and this will be an interesting matter to see. So mostly it's some beach resorts or something people want to build up. So here that's a public place, and this one has to be properly done. So that will be, we are not there yet. I hope we are there soon, and then we're going to talk again. I hope.
Looking forward to it. I don't know if we still have Professor Ogunsua. Looks disappeared. In the meantime, just looking at the clock. Professor, one question for you regarding the recommendations for treatment before lamination, if you can share your experience on that.
For me?
Yes.
Yeah, good. For the particular experiment that we carried out, we also treated. We treated, and then we also tested the stakes on the field and in the lab. Those ones were published in subsequent works that have been published, and then we have a good result. Since then, we have also adopted several methods in the local wood lamination that we do at the laboratory level here. What we have found out is that bamboo being having high level of sugar, within 2 days in the laboratory, they are already being attacked. Mm-hmm. So what we do is that we put them in a very big tank of boric acid in solution. So once we have been able to do this, we have been able to do this for years, and it has worked. That within the period that it is outside, we have it intact. And we have additionally made efforts to treat them severally with biocides like we have done the CCA in the past. We are no longer doing that. Ricinus communis, that is a castor seed oil we have extracted to treat bamboo. Results have been published and found to be very durable when we do that. We have also done leaf extracts of Azadirachta indica to also treat. And these ones, you see the color of Azadirachta indica, when you treat with the extract, it looks exactly like when you are using CCA, chromated copper acetate, the same color. But because the extract of Azadirachta is biodegradable, we fear that it has no problem in the utilizations potentials in areas where we can have parks and so on and so forth. So we have tried so many things, so many aspects of treatment, and all these ones have been published. They're in public domain.
Okay, thank you very much. I'm really sorry, but we ran out of time. Before there's still a couple of questions more. Maybe we can share them afterwards via email. I would like to now invite you all to open your cameras so we can make a group picture of our first session of this year's seminar.
Okay, Qinghui, could you help for the group photo?
Okay. Okay, everyone, please open your camera. Okay.
Smile.
Just wait a second. Okay. Okay,
Perfect.
we
Thank
have
you.
done the group photo. Thank you very much.
Thank you very much.
Thank you, everyone.
Well
I
done
hope
on it yourself.
we see each other next week.